The next lesson we're going to be working on is, again, a large multiplication strategy. It's called the box, and it's based on using one of the strategies we had before. I'm going to be using some manipulatives in this one just to help us out. If we have a multiplication equation, 9 times 2, we can really show this equation with what's called an array. And if we put 2 rows of 9 all the way across. There's 1, 2, 3, 4, 5, 6, 7, 8, and I think I can fit one more on the screen here, right there. So this is a row of 9, 1, 2, 3, 4, 5, 6, 7, 8, 9, and 9 times 2, which means there's 2 rows of them. So how many do we have? We can count by 2s here. Either way, count them all up. 2, 4, 6, 8. And we'll end up with exactly 18 dots here. So 9 times 2 is 18. Why? Well, because if we have 9 groups of 2 or 2 groups of 9, we get 18. That's just what we have. So this is a visual representation, and it's called an array. We can take this same idea and expand it a bit farther. What if we said it was 19 times 2, or 9 times 12. Well, I'm going to say it's easier to do 9 times 2, or 19 times 2, so we're going to do that, but we're going to use another visual representation. So for 19 times 2, I'm not going to use those marker dots again because they're just too big for the screen, but what I will use is I'll use our base 10 blocks for this one. So I still need to make 19, and there's 2 groups of that. So the rod is worth 10 because if you can see it in here, there's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 little squares which are relatively equal to one of these suckers. And so I need to make 19. There's 5 plus 3 more, and 1 more makes 9. So that is my representation of 19. I can do the exact same thing here. Put them all together. There we go. 19. So I have 2 groups of 19. And I can look at this and I say, well, I have 2 10s, and then I have 2 groups of 9. So I can write this into a box right now. I can make this physical model a pictorial model by simply drawing it out into a box. I'll just draw a little rectangle. And because I have 2 digits here, and I have 1 digit here, I'm just going to cut it into 2 squares. So 19 are my 10s. So I have 1 10, and then I have 9 1s. Here's my 9, and here's my 1s. And I'm doing 2 rows of it, so here's my 2. So how many 10s do I have? I have 2 10s. 2 10s is worth 20. Now I have 2 groups of 9, which are all these 1s here. So 9 times 2, as we already figured out, was 18. So I've broken it apart, and I can multiply these together, and I'll end up with 20 and 18, and that equals 38. Now, what if we wanted to go bigger? We're going to take the number now, 14, and we're going to multiply that by 23. We're going to use this box again, but we'll model it out once more with the base 10 models. So to make 14, I'm going to use a big block here. Why am I using a big block? Well, this is 100 block, and it goes 10 this way and it goes 10 that way. I know in my model I'm going to need to go 14 high, and I'm going to need to go at least 23 across, so I'm using this guy. So to go 14 high, that's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, plus 1, 2, 3, 4. And I'm just keeping it a rectangle. So again, I'm going for 23 by 14. So here's my 14. There, I just made 20 going that way. And my number again was 23, so I have to go 23 this way. I can do that by adding 3 more to the length of my rectangle, and then I just need to fill in the middle. All of these little spaces here are my little ones. So let's see here, there's my 3. Okay, so we can see this little rectangular model, which is again just like making the array but on a large scale. I have 14 going this way, I have 23 going this way, and just now it's a matter of figuring it all out. I can see there's 2 hundreds here. I have 1, 2, 3, 4, 5, 6, 7, 8, 9, and 10. Tens, which is exactly the same size as a 100 block. So now I have 3 hundreds. I have 1 10 left, and I have 1, 2, 3, 4, 5, 6, 7, 8, 9. And if I steal one more, that gives me a 10. I can regroup that one out and just give it a rod. And I'm left with 2 ones. So in the end, I can save just from the physical model, I have 322. But let's see if this works out, and we'll play it out into our box model. So remember 322. So using the box again, I have a 2-digit number by a 2-digit number, so I'm going to make a bigger box. Make it a little bit more square. And I have 2 numbers to go this way, and I have 2 numbers to go this way. When I say 2, 2 digits, 2 digits. So I'll say 20 and 3, I'm expanding it out, and 10 and 4. Now 10 times 2, I'm just going to multiply these together, kind of like the battleship model. So 10 times 2 is 2 with 2 zeros. 1 times 3 with a 0. 2 times 4 is 8 with a 0, and that gives me 12. If I add all these up together, 200, 80, 30, and 12, I now have a 2. 8 plus 3, but oh, that's a 12. 322. Exactly the same as I had when I did my physical model, but I'm just making a pictorial mathematical equation, making it a little more concise. It organizes so that I've broken it. I'm still multiplying the 4 by the 2, the 1 by the 2, the 4 by the 3, and the 1 by the 3, but it gives a nice and concise model. This works for 2 and 3-digit numbers. Getting 4 and higher gets a little bit more complicated, but for the smaller ones, this is a really nice way of organizing your work. And that was our next lesson.